Atterberg's limits. Atterberg's limits are the consistency limits. They are determined for fine-grained soil, namely the clayey soils. These are the index properties. They are indicative of the engineering properties of the soil. The Atterberg limits are the water content of the soil. The water content is given as the ratio of weight of water in the soil to the weight of solid soil particles. Consistency. Consistency is the physical state at which the soil exists. Depending on the water content, the soil can exist in four states: liquid state, plastic state, semi-solid state, and solid state. In the liquid state, the soil will act as a liquid. In the plastic state, the soil can be molded to different shapes. In the semi-solid state, the soil will crack upon molding. In the solid state, with the reduction of water content, the volume of soil will remain constant. The water content at which the soil changes from one state to other are called the Atterberg's limits. It is important because soil having the same Atterberg limits will behave similarly. The soil is a three-phase medium. If it is not saturated, the soil will have solid soil particles, water in the voids, and air in the voids. If it is saturated, the soil will be in two phase. That is, there will not be any air in the voids, it will be filled with water. In the liquid state, the soil is having high water content. In this state, the soil will act as a liquid. There is no shear strength in the soil, that is, there is no resistance to any form of deformation. It is important to note that the volume of water in the soil is more than the volume of voids. Liquid limit. Upon reduction of water, there will be a reduction in the volume of soil. The soil will reach a particular water content at which the soil will start showing minimum shear resistance. The minimum shear strength will be around 1.7 kN per meter squared. That water content is called the liquid limit. Or we can say that the water content at which the soil changes from liquid state to plastic state is called the liquid limit. Plastic state. Below the liquid limit, the soil enters the plastic state. Here the soil possesses shear strength. It can be molded to different shapes without cracking. Plastic limit. When the water content is reduced in the plastic limit, the soil will reach a particular water content at which the soil will start cracking upon molding. That particular water content is called the plastic limit. Semi-solid state. In the semi-solid state, the water content is below the plastic limit. In this state, the soil will start cracking when it is molded. Shrinkage limit. With the reduction of water content, the volume of soil will also reduce. It will reduce up to a particular water content. That water content is called the shrinkage limit. Below the shrinkage limit, air starts entering the voids. It is also important to note that below the shrinkage limit, soil is no longer saturated. This picture shows the soil in four different states. A summary. A soil containing high water content is in liquid state. Here, the shear strength is equal to 0 and the soil keep acting as a liquid. It is important to know that the volume of water in the liquid state is much more than the volume of water that is required to fill the voids. As the water content reduces, it enters the plastic state, and on further reduction, it enters the semi-solid state. In these two states also, the volume of water is much more than the volume of voids. When the water content reduces and enters the solid state, the volume of soil starts to remain constant. In the solid state, air starts entering the voids. For better understanding, let's plot a graph between the volume of soil and water content. As mentioned before, the volume of soil reduces with water content from liquid state to plastic state to semi-solid state till it enters the solid state. The soil in the solid state will have a constant volume. The liquid limit is the water content at which the soil changes from the liquid state to plastic state. The plastic limit is the water content at which the soil changes from plastic state to semi-solid state. The shrinkage limit is the water content at which the soil changes from semi-solid state to solid state. Hope the video was clear. Thank you.